Okay, so we're continuing on from, and we're still in section 10.2, combinations. Today we're going to be doing Pascal's triangle and the binomial theorem. So you guys have two triangles on your page. Right now we're just going to focus on the one on top. So the thing you need to know about those triangles is, first of all the edges are ones. So you can go ahead and fill all the ones in. Then, to fill in the other ones, what you do is you look at the two squares that are touching it. So I've got a 1 and a 1. I add them together, and what does that equal? 2. If I go to the next row, here I have a 1 and a 2, so what does that equal? 3. So you guys get how it works? Yeah? So what else is going to be in that row? Another 3. Okay? So I want you guys to finish filling that out while I come around and stamp homework, okay? All right, so we got Pascal's triangle filled out all the way down to the 11th row. So it turns out there's kind of this cool thing about Pascal's triangle. I went ahead and cut and pasted the top part of it up here. It turns out that the very first row, I'll call that the 0 row, that this is the same as 0, choose 0. And then for my next row, I've got 1, choose 0, 1, choose 1. Those both equal 1. And then the next row, 2, choose 0 is 1. 2, choose 1 is 2. 2, choose 2 is 1. So it turns out that this works out with our combinations. And so what the next row, I'm going to be 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. And then the next row, it's 4, choose 0, and then it's 5, choose 0. And the next row would be starting with 6, choose 0, and then it'd be 6, choose 1, 6, choose 2, 6, choose 3, 6, choose 4, 6, choose 5, and 6, choose 6, right? So, so Pascal, he was this French mathematician, and he noticed this pattern, and it's kind of cool. So if you want to start filling out your bottom triangle with the combinations, you don't have to fill the whole thing out right now, but if you want to at least get, say, the first 3 or 4 written down, why don't you do that right now? And then after you've filled that in, at least part way, write down the sample problem we're going to do together also, okay? Okay, so let's take a look at this problem here. I've got 6 members of the Model UN Club, and they must choose 2 representatives to attend the state convention. So I've got 6, and I want to choose 2 of them. So let me add my 6th row on here. What was it? 1, 6, 15, 20, 15, 6, and 1, right? So my first spot, that's 6, choose 0, 6, choose 1, 6, choose 2. What's the answer? 15. So it works like a shortcut, doesn't it? Instead of doing, you know, your 6 factorial, 2 factorial, 4 factorial, I can just look at the triangle and count from 0, 1, 2 and figure it out. Kind of cool, huh? Yeah. So any questions about what I just did there? All right. So where you're going to use this a fair amount tonight is with the binomial theorem, which is coming up next. All right, so the binomial theorem. This looks like really, really complicated the way it's written out. But once I show you an example, I think it'll make more sense. It might take a couple examples before the light bulb goes, oh, I get what she's doing now. But go ahead and look at it. What's gonna happen is that the coefficient for my first term is n choose 0. Notice the n is your exponent. So if I was doing something to the 8th power, my first one would be 8 choose 0. And then it'd be 8 choose 1, 8 choose 2, 8 choose 3. So see, that's what they're doing here. They're counting up until they get to It would be 8 choose 8 if it was my example with the 8th power, okay? And then what else is happening is that the coefficients on the first term, the a, are counting down. First I have n, then I have n minus 1, n minus 2, until it gets all the way to 0. So in my example with the 8s, it'd be 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1, then 0. Okay? And then the opposite is happening with the b. That's starting at 0 and counting up until I get up to the number of the power. So in the case of, if we were doing it to the 8th power, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8. So before we knew about Pascal's triangle or the binomial theorem, to figure this out, you guys would have to just manually multiply this 4 times, right? Oops. I said the number 4 and I went to write it. Okay, so we'd have to do x plus y, x plus y, x plus y, x plus y, right? But now with the binomial theorem, I can use combinations to figure out the coefficients and essentially go straight to my answer. So my first one, my power is 4, right? So first I'm going to have 4 choose 0. And then my next one, I'll have 4 choose 1. Then I'll have 4 choose 2. Then I'll have 4 choose 3. And finally I'll have 4 choose 4. Then I take my first term, so in this case x, and I'm going to start with x to the 4th, and I'm going to count down. X to the 4th, x cubed, x squared, x to the 1st, and x to the 0. For the last term, I'll go the opposite direction. I'm going to start at 0 and count up. So y to the 0, y to the 1st, y squared, y cubed, y to the 4th. And we've got plus signs between them. So now all I need to do is simplify this and I'll have my answer. So right now you're probably thinking, okay, well this looks way more complicated than just multiplying it. But we can use Pascal's triangle, and if we know what our power is, we can go straight to writing the coefficients. For expanding the whole thing, you don't necessarily have to write this step out, but I wanted to make sure you guys understood where it came from. So let's take a look back at Pascal's triangle. Look at the row with the 4s in it. We're using this row right here, right? 1, 4, 6, 4, 1. Right? And that's 4 choose 0, 4 choose 1, etc. Okay, so I'm going to just take those numbers. 1, 4, 6, 4, 1. I've already figured out my combinations, and then I'm going to simplify it. So x to the 4th, y to the 0 is just x to the 4th. And then x cubed, y to the 1st, so x cubed y. X squared, y squared. Xy cubed. And then y to the 4th. Any questions on this? Okay, so one of the things I want you guys to notice is that when you're doing this, these coefficients always add up to your power of 4, which is also the same as how many you're choosing from. So 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and 0 plus 4 is 4. Okay? So if those don't all add up to the power of the binomial, then somewhere you messed up when you were counting up or down, and you just skipped something or whatever. But those powers should always add up to the power of the binomial. Okay? And then another thing that happens is that the 0 here matches the exponent on my y term, or the second term. 1, 1, 2, 2, 3, 3, 4, 4. So any questions about that? You ready to tackle one on your own? Or semi on your own? Okay, so for this one, what I'm saying is you don't have to write down the combinations. What's my power? 3. So look at your Pascal's triangle. What's the row that's got the 3's in it? What is that row? 1, 3, 3, 1. So you've already done your combinations, okay? So now just figure out what goes after those numbers. Okay, so it looks like you guys are getting it. So my x's, I'm going to start at x cubed and count down. And I'm not going to worry about x to the 0. And then my y's, I'm going to count up. Well, and I don't need to write I think that should be squared. And then y cubed, and then just put your plus signs between it. Okay, so now I'm going to show you another example. But now instead of just having an x and a y, I have some coefficients inside my binomial. And now I'm subtracting. It's a minus 2b to the 4th. So what you need to realize is that whole thing, the negative 2, goes with the b. All right, so that's your second term in the binomial. So we're on the 4th power again. So what are my numbers for the 4th row? Right, we had 1, 4, 6, 4, and 1. And then I'm going to, for my a's, I'm just going to be counting down. So a to the 4th, a cubed, a squared, a to the 1st, and then a to the 0, which is 1. Now, for the second term, I've got to take that whole thing and raise it to the power. So the whole thing raised to the 0 power is going to be 1, so I'm not going to worry about writing it on my first term. But then for this next term, I've got negative 2b, and I'm raising it to the 1st power. Then I've got negative 2b to the 2nd power, negative 2b to the 3rd power, and negative 2b to the 4th power. Everybody follow that? Okay. So now I'm going to go through and I'm just going to simplify each of those. So let's see here. All right, so this is going to be 4a cubed, and then it's just times the negative 2b. What does that equal? What's negative 2 times positive 4? It's negative 8, and then I have my a cubed b. All right, for the next one, I've got the 6a squared, and I have to square negative 2b. What's negative 2 times negative 2? Everybody, what is negative 2 times negative 2? Positive 4, and then b times b is b squared. So if we multiply 6 times 4, we get positive 24, and then we've got a squared, b squared. All right, then over here I've got 4a, and what's negative 2 to the 3rd power? Negative 2 times negative 2 times negative 2? Negative 8, and b cubed. So 4 times negative 8 is negative 32, and then a b cubed. And then finally, negative 2 to the 4th power is 16, and then we have b to the 4th. All right, so any questions on what I did there? Do you notice that what happens with our signs? They end up alternating, and that's going to always be the case when you have a minus sign, because when the exponent's negative, it's going to be negative. And when the exponent's odd, it's going to be negative. But if the exponent's even, it's going to be positive. So that's always going to happen where it alternates like that. All right, so here's one for you guys to try on your own, on your whiteboards. All right, so you should have ended up with 16x to the fourth minus 32x cubed y plus 24x squared y squared minus 8xy cubed plus y to the fourth. Questions on that one? We're good? Thumbs up, thumbs down. All right, so we're also going to have some problems where they want to know the coefficient for just one of the terms in the expansion. So instead of having to find all 8 terms of this expansion, I'm just going to find the one that has the x to the fifth. Okay? So it's x to the fifth. That's my first term. My second term is 2. What power am I going to have to raise that 2 to? What do the exponents have to add up to? They have to add up to 7. So 5 plus 2, right? So it has to be 2 squared. And then I know that I've got a total of 7, so at 7, choose 2. Because remember we talked about how those match also. So which row of my Pascal's triangle am I dealing with now? The 7 row, right? All right, so let me go back over to where we had the triangle, the whole thing. Okay, so I'm talking about this row right here with the 7s in it. So my first one, that's 7 choose 0, 7 choose 1, 7 choose 2. So 7 choose 2 is what? 21. So I can go back over now. And that's going to equal 21 times x to the fifth times 2 squared, which is 4. And so that's 84 x to the fifth. So the question is just asking for the coefficient, so the answer would just be 84. Okay? Yes? Where the 5 came from. Because that was what was in the original problem, what they were asking for. They were asking for the coefficient for x to the fifth, so that's how I knew it was x to the fifth. Right, if they had asked for x to the fourth, then it would have been 2 cubed, correct. Yeah. And then it would have been 7 choose 3. Okay? All right. So last period, somebody noticed that if they made a mistake, and they did 7 choose 5 x to the fifth 2 squared. Let's go back over and see what happens if I accidentally put 5 instead of 2. There's 2, 3, 4, 5. What happens? I got the same number. So for whatever reason, when they set up the binomial theorem, they decided to count up on the they decided to count up, but you could have also gone the other direction because Pascal's triangle is symmetrical, right? Mm-hmm. So if you want to go the other direction, it actually doesn't matter. As long as if you have a 5, if you're doing something to the fifth power, you need to have either a 5 or a 2 down there. Okay, so that'll actually work also. You still end up with 21 times 4 times x to the fifth. So. All right, so here's one for you guys to do. So it's up to you. You can make it match the x cubed or you can have it match the other one. So for this problem, the coefficient of x cubed in 2x plus 5 to the 8th power, be careful, first of all, because there's a 2 in front of that x. And what do your coefficients have to add up to? 8, okay? Okay, so when you guys are doing this, I'll write with a fancy pen now. I feel like it. Okay, if I've got x cubed, what that means is I'm actually taking that 2x and I'm cubing that. And so for my 5, what does the power have to be? To the fifth, because 3 plus 5 equals 8, right? Those two Have to add up to 8. Okay, now out in front then, I've got 8, choose 5, or you could have done 8, choose 3, and that would have worked also. So if you look in your 8th row, what does that come out to? 56. And then 2 cubed is 8. You got to remember to cube the coefficient as well, not just the x, but the 2 also. And then 5 to the 5th power was 3,125. Right. So if you multiply those all together, it came out to 1.4 million, yeah, 1,400,000 x cubed. And again, if they're asking for the coefficient, really the only part that's your answer is the 1.4 million. Okay? All right, any questions? Okay, so you guys can use your triangles tonight. And actually, number 19 was for you to finish making the triangle, so you've already done it essentially. I'm not expecting you to do it again on your paper. You've already done number 19, okay? All right, that's it for today then.